طيب معلش الصوت كان ناطط. طيب يا شباب، السلام عليكم ورحمة الله وبركاته. هنبدأ اليوم التجربة الخامسة من تجارب الإلكترونيك سيركتس فور تيستينج فور. التجربة هي تجربة الكونستانت circuit application circuits. Two parts. Part A constant current source. هنبدأ ببارت A constant current source اللي هي الدائرة في فيجر 3. في فيجر 3. طيب الدائرة في فيجر 3 عندنا فيها الأوب أمب، تمام؟ عندنا فيها R1 1 كيلو أوم، عندنا فيها variable resistor 10 كيلو أوم، تمام؟ عندنا كمان أميتر في الأوتبوت، ده حيكون هو الأميتر في الأوتبوت، أوكي؟ وعندنا feedback resistor as R load according to table 1. هنغير المقاومة هنا according to table 1، تمام؟ طيب توصيل الدائرة زي ما هو معتاد، عندنا الأوب أمب بلس 15 و ماينس 15، تمام؟ عندنا كمان هنا 10 كيلو اوم variable resistor to plus 15 and minus 15. اوكي طيب، وعندنا non inverting of the op amp is connected to ground. Okay, so from the 10 kilo ohm we have the input connected to 1 kilo ohm, and 1 kilo ohm is connected to inverting input, and at the same time to the R load, which is the feedback resistor. Okay, so here we have the output from the 10 kilo ohm to voltmeter 1 to ammeter 1 to read the voltmeter, and then the ground is connected to ground here. Okay, next and pay your attention with me here. For the output or for the load, we need to record the current, I load, and the voltage. So according to the circuit, follow me. According to the circuit, the output from the op amp should go to the negative of the ammeter. So here is the negative of the ammeter. Okay. Okay, and then from the positive of the ammeter, we have chosen 2 ampere max. Okay, from here to, as you can see, from here to R load, and for the output V load, you can see the circuit from this point to here. Okay, and then the common to here. Okay, make sure you understood the connection very well. Here is the ammeter, so we have chosen milliampere, and here the scale is 20. Okay, milliampere and scale is 20. Okay, and here is volt. Okay, scale is also 20. Okay, here is volt, scale is also 20. Okay, now let us operate the circuit on. The voltage in the input here is adjusted to 2 volt according to step 7 in the procedures, to adjust the input to 2 volt. Okay, and then according to table we have to connect R load 0.1 kilo ohm, which is 100 kilo ohm. Already we have connected 100 ohm, which is 0.1 kilo ohm. So now we need to record the minus VL and IL. Okay, so minus VL is minus 0.22. Okay, minus 0.22 volt, and the current in milliampere is 2.02 milliampere. Okay, now let us apply the second R load, which is 0.33 kilo ohm. 0.33 kilo ohm is equal to 330 ohm. 330 ohm. I will connect it here. 330 ohm. So this will come here. And this will come here. Okay. I have changed the R load to 330 ohm. And then let us operate the circuit again. Here is 2 volt. Okay. The minus V load is minus 0.68, minus 0.68, and the current is still constant, 2.02 milliampere. Okay. Next, let us connect the third resistor as R load, which is 1 kilo ohm. 1 kilo ohm. Okay. Let us find 1 kilo ohm here. I'm trying to find 1 kilo ohm. Yeah, I put it 1 kilo ohm. So here is 1 kilo ohm. I will take this one. Now we will connect 1 kilo ohm. As you see, we are changing the R load, which is a feedback resistor. So 1 kilo ohm. Now the input voltage is 2 volt, and the V load is minus 2.04, minus 2.04. Okay, and the current is still stabilized in 2.02. 2.02. Okay. Next, we have to connect a load resistor that's equal to 2.2 kilo ohm. Okay. Let us connect 2.2 kilo ohm. This is 2.2 kilo ohm. Okay. And then when we connect 2.2 kilo ohm, we see that the input voltage is 2.01, almost 2 volt stabilized, but the output voltage is increased. The load voltage increased to minus 4.5, but the current is still stabilized, still constant. We are changing the R load, which is the feedback element, but the current is constant while the voltage is increasing. Okay. Okay. Next, 3.3 kilo ohm. 3.3 kilo ohm. Okay. Here it is. I will change it. 3.3 kilo ohm. Let us see again. The input voltage as it is. The output voltage increased to minus 6.75. Minus 6.75. And the current is still stabilized. The current still stabilized. Okay. Next, we need to connect 4.7 kilo ohm. 4.7 kilo ohm. It is here. So I will change this to 4.7 kilo ohm. okay, to here, and this one to here. So this is 4.7 kilo ohm. You can see the input voltage stabilized, and the load voltage minus 10.56, and the current almost stable, stabilized on 2.02. Okay, so for this part, we have seen that while changing the load resistor, which is connected in the feedback, okay, we got a variable output voltage while the current is stabilized at a value 2.02. Then we have a constant current source from this op amp. That means from this circuit, okay, between this terminal, okay, this one and this one here, we can connect any load, and we will have a constant current for this circuit is 2.02 milliampere. 2.02 milliampere. Okay, let us. Okay, if it is okay, it's clear. Let us go to the second part, which is a voltage source, and then reconnect the circuit according to figure 5. We have the op amp, and from this op amp, okay, we don't have an input resistor, so we have 1 kilo ohm. We have 1 kilo ohm. This is 1 kilo ohm. And in series with this 1 kilo ohm, we have a Zener diode. According to the circuit here, the Zener diode is 6.2, but I'm using 8.2. I couldn't find 6.2, so it is 8.2. Connected like this. The cathode is up. Then we have to apply minus 15 volt to 1 kilo ohm. Okay, and from 1 kilo ohm to Zener cathode, and from Zener cathode to ground. Pay attention that the output from the second terminal or the anode terminal of the Zener diode is connected to ground, not to minus 15 volt. Okay, so we have op amp connected to plus 15, op amp connected to minus 15, but the anode terminal of the Zener diode is connected to 0. Okay, as per the circuit. Now let us come to the connection of the input. Now the input is connected to the non-inverting, as you can see in the circuit. Okay, so the non-inverting is connected to, I will change this cable here. The non-inverting is connected to here. Non-inverting to here. And the inverting is fed back. The inverting is fed back to output. So if we fed back, direct feedback without a resistor, that means the op amp will be in which configuration? It's a voltage follower. Now let's connect the load according to table 2 First of all, R load is infinity, which means that it is an open circuit, which means that it's an open circuit. Okay. Then how we can take the output voltage? Follow me. So now we need to change this to output voltage, or maybe I will use this one directly. Forgot about this one. So this is for the input and this is for the output, and both of them are connected to ground. Okay, are connected to ground. Okay, so if we connect directly here, that means we will have an infinity output resistor. Okay, an infinity output resistor. Okay, so let us revise the connection quickly. We have, follow me in the circuit, we have minus 15 to here, to 1 kilo ohm. Then this connected to Zener diode, and from Zener diode to ground, and the op amp is plus 15 minus 15, and then from Zener anode of cathode of the Zener diode directly to non-inverting input, and the inverting input is directly to output. Okay, okay, and then here is for in the input. Okay, connected to okay, let us connect the input voltage to here. Okay, the input voltage. Okay, and this is the output voltage. Okay, so to start, we need to read the output voltage. You can see the output voltage is 8.19, which is almost 8.2. Don't forget that the Zener diode is an 8.2 Zener diode. That means the Zener voltage is 8.2. Okay. Now let us change the resistor, the output resistors or the load resistors. Now we need to have 5 kilo ohm. So I will choose the 1 decade. This one. Hope no, it's not multiplied by 1 kilo ohm decade. Yeah, I got it. It's here. So now we will connect this one. Okay, how it is connected? I can show you the circuit here. This is the circuit. So this is the R load connected from here, and this other terminal to ground. Okay, so the nearest ground, I will take from the nearest ground from here to the nearest ground. It is here. You see, this is grounded. Okay? You see, this is grounded. Then this is the nearest ground, and from here we'll connect this to here. And we will take the output from here. Okay, take the output from here. Okay, now let's adjust the values of R load according to the table. 5. Here is 5 kilo ohm. 5 kilo ohm. Then we can see that the voltage is stabilized. Here is the Zener in the input, across the reading across the Zener, and here is the output across the load. Okay. Okay. Now I will switch off the circuit and then see it again. See it again. Okay. Let us. You see. Okay, now 4 kilo ohm. It is 4 kilo ohm. Okay, still nothing changed. Nothing changed. Now 3 kilo ohm. 3 kilo ohm. Okay, nothing changed. Now 2 kilo ohm. 2 kilo ohm. Also nothing changed. The input and the output. Now 1 kilo ohm. And still nothing changed. And then we need to apply 0.33 kilo ohm, which is 330 ohm. 330 ohm. Yes, this one, 330 ohm. Instead of this one, we'll change it. I will put 330 ohm. So as you can see, this is 330 ohm. Okay. So now when we have changed to 330 ohm, we can see, I will stop this. And now the input voltage is 8.19. The output voltage is a little bit decreased, 5.69 when we connect 330 ohm. Actually, it's supposed to have the same value, 8.2, but it gives 5.69. I don't know why. This is what it has given. Okay, so yeah, same connection. Okay, same connection. Same connection. Maybe this is due to the little bit higher Zener diode we have chosen. Instead of 6.2, we have chosen 8.2. So just only record this value. Okay. Okay. So that's all. Record these values in the tables and submit the report. Okay. Thank you so much.